Good morning, everyone. My name is Ayrton Coles, and on behalf of our Tennessee Transportation Assistance Program, we welcome all of you to our Raising the Bar, How Artificial Intelligence is Revolutionizing Traffic Operations webinar. We'll be here for the next hour. I'd like to say thank you to all of you participating and as well to our instructor, Brent Rogerson, with over 17 years of experience at MyoVision. Brent currently serves as the Director of Solutions Engineering, where he is dedicated to accelerating the digital transformation of traffic signal infrastructure. A specialist in smart city ecosystems, Brent leads a team focused on delivering measurable outcomes in improved congestion, air quality, and road safety. His technical expertise spans a vast array of cutting-edge technologies, including video detection, V2X communications, cloud platforms, and adaptive systems. By integrating emergency preemption, transit optimization, and sophisticated signal performance analytics, he ensures that municipal agencies can solve complex urban challenges through data-driven insights. Brent is a graduate of Wilfrid Laurier University with a degree in geomatics, where he specialized in GIS, spatial analysis, and urban behavior, a foundation he uses to bridge the gap between advanced network performance and the human element of city living. So thank you again, Brent, for participating. Make sure that you check our TTAP calendar when you have a chance. We keep adding more classes to it. I would also like to remind you that this is a webinar, part of our transportation industry showcase webinar series, where we are partnering with vendors to bring you more information about transportation technology and how you can improve operations and transportation infrastructure from your agency side. Okay. Last but not least here, please sign in typing your full name in the chat box. If you have anybody else with you in the office or attending this, make sure you add their names as well. Use the chat box to ask and answer any questions, and please address questions and comments to everyone in the meeting. I will be sending your certificate soon, but please allow us 2 weeks. We need to check if you participated at least 90% of the session. And workshop materials are available for download. You should have received an email from Zoom where you can download the materials, but I will add the link to the materials as well on our chat box. So thank you again for all of you participating. Thank you for Brent to agreeing to help us out with this. I'll stop sharing and I'll let you run the show, Brent.
Awesome. Thank you so much. Let me share my screen here. All right. All right, thank you so much for having me. I'm going to talk a little bit about some Gen AI applications and how we've put it to work into the transportation industry. I'll try to cover some real world use cases that we're already seeing active in the field and some of the exciting data sets that are starting to come together and become produced. So I'm gonna talk a little bit about MyoVision, just so you know, kind of my background a little bit. Our intelligent mobility platform to try and unify the data sets for Gen AI tool sets. The Gen AI agent itself is going to be a bulk of the discussion here, where there's a lot of really fun stuff around how AI is applied. Some of our AI studios and our workspaces that we're starting to leverage, and see how far I can get into those use cases. I will probably focus mainly on one kind of specific use case around how safety data is coming together. There is a lot of use cases to cover, so I'll probably focus on the one to show you the range and the power of the one use case. But there is a whole lot more, and I'll try to leave some time at the end. So you already got a little bit of an introduction of myself. Thank you for that as well. And thank you for having me on this session. There's a lot of really fun and exciting details. So my journey is, I don't know if it's unique, but it's been a very interesting process. I actually started at a startup company called MyoVision years ago, back in 2008, where we had this idea to build computer vision technologies where instead of us sitting at the side of the road counting cars manually, we got a camera to start counting them for us. If anyone sat at the side of the road and counted cars, you'll know exactly what I'm talking about. And that's where our product, the Scout, came from. If you're familiar with the Scout, it's effectively a camera on a stick, and it allows us to record the intersection and produce video-based analytics. So I spent a lot of time building that out, spending a lot of time in the machine learning aspects of that, and building out the very first data collection tool in our ecosystem. We have grown quite significantly since that moment. And we spent a lot of time around North America helping with a lot of different usability or mobility or congestion challenges. And we've also integrated a lot of technologies together. So we focused a lot on the production of data and the creation of the ecosystem. We spent probably the last 15 years creating that ecosystem. And that allowed us to build distribution partners, massive amount of cities that we work with. We are a smart city partnership with AWS and some major data platforms like NVIDIA. All have come together to build this intelligent mobility platform that produces a significant amount of data that cities are now starting to adopt and leverage. So um, that's a little bit about MyoVision. MyoVision is in about 68 countries now in total, but our main focus is on North America. So we do spend a lot of time. In total, out of all of the intersections in North America, I would say MyoVision is covering close to one third of them in some way at this point. We have the largest connected ecosystem in the industry, which allows us to produce the most amount of data. So let's talk about that intelligent mobility platform first before we get to the AI. This is a critical step in the process. I'm not necessarily going to show this as, don't think about this as like a MyoVision product overview. I just want to uh, really show you the capabilities of what data is being produced and how the Gen AI is trying to navigate some of that data. So think of this as a little bit foundational, this section around what the data sets are in the platform. So first is what areas of a city do we focus on? I often talk about the city ecosystem, the different departments that use the roadways, but also focus on them a lot. So think traffic operations. This is signal management, detection, understanding the infrastructure. How is it working? We provide obviously a detection product to help with that, with the signal actuation and cycling. So traffic operations, alerts, maintaining the network is a big part of our business. The next is transportation planning. So this is where a lot of the data that we produce goes. It goes to the planning engineers, where we combine our portable cameras, a permanent device set that allows us to produce some of the roadside analytics, as well as all of the performance data on top of that. Next is emergency vehicles. Getting vehicles through a network. So think active management of a network. Not only are we trying to improve congestion or make roads safer for pedestrians, bikes, or more vulnerable road users, but we also have the reality of moving emergency vehicles quickly through that network and safely through that network. So we connect them into this ecosystem and effectively provide them preemption through the network and priority through the network. And then the second is transit. So trying to move more people around the city. It's very important to make sure our transit operations are integrated into that network because we need to improve our schedule adherence as well as our capacity to move people through public transit. And then lastly, the entire V2X ecosystem. We have a significant number of vehicles already connected, streaming off some of those data sets. So it's a two-way communication with a large set of vehicles on the road, one providing them with signal status and additional information, but also receiving them as probe-based data so we can actually develop performance measures off of probe-based data beyond the intersection itself. Basically creating an ecosystem of all of these aspects working together. So just quickly, our little wheel of data sets that I'm going to be talking about in this discussion. So we have the vehicle preemption data that I was just talking about, the transit vehicle data, a large set of what we call multimodal traffic insights. So think volume, classification, speeds. Then on top of that, there's the signal telemetry, real-time statuses of the intersection itself. There is all of the signal timing plans themselves. So how is an intersection programmed? The mapping in GIS, the spatial context. We have actually mapped out curb to curb, lane to lane, asset to asset of almost every intersection in North America, allowing us to overlay this data. We have all of our portable studies on top of that, as well as our video detection and hardware integrations. So a lot of different data sets that MyoVision produces. But in addition to this, we're actually integrating third-party data sets to increase this ecosystem. So think TomTom, think citizen complaint workflows, think open data portals, basically anything that exists, we're trying to integrate into the intelligent mobility platform itself. I'm not going to get too much into the how, but we do this through connecting two city networks through a system called Network Core. And if they don't have a strong network or a way for us to connect into the network, we use a device that you can see here on the right. This device is not only a switch, a modem, a communications device to connect into the traffic network. It is also our graphic processor units at the side of the road that produce a significant amount of data. So in terms of the network, so as we're starting to put some of these building blocks together, these building blocks look like a network map. It looks like nodes on a map. You can see some live signal status. You can start seeing some of your video-based assets. You can start seeing current alerts that are operational. So basically trying to overlay the live data sets as well as some of the historical data sets directly on the map so that we can see basically what's happening in our network all in one place. Then you go a little bit deeper right into the intersection level map. When you go right down to the intersection level, you start seeing a much higher resolution of data. So it would be the signal status, detector data, vehicle trajectory data, data that then can allow us to produce insights like performance measures, counts, compliance, clearance, conflicts, and probe data. So I specifically called out a few different data sets here and think general mobility. Think like what are the aspects of actually creating a safer design, or what is the mobility of an intersection. So that means performance measures is what produces our progression for us. Turning movement counts gives us relative sense of how many and what vehicles. Compliances, are they adhering to the signal itself, like red light runners as an example? Are they crossing the roads with the crosswalks, or are they crossing when it says don't to cross? How long does it take a person to walk across the road? How fast vehicles are driving? How long it takes to move through the network, and so on. And then lastly, the conflict data of where do these objects become really close to each other and potentially cause unsafe conditions. And then lastly, layering all of that between the intersection that we don't necessarily produce with probe-based data that allows us to do like origin, destination, and so on. So a large, high-resolution data set. So just to show you how, if you go deeper and deeper down it, this is basically a computer vision view of us capturing all of the vehicles in the frames, identifying them, classifying them, understanding where they're moving, tracing them, creating trajectory. This is a foundational layer of a type of AI called machine learning, where we're actually not only building models of what does a vehicle look like, what are the attributes of a vehicle, but building out the model set around how do they interact to each other? What do we expect of them? How fast do they move? What are some of the behavioral traits of a truck versus a bike versus a bus? And those types of models exist behind the data sets. And it's important to start recognizing the types of AI that can exist in terms of our industry and the traffic industry. So the very first one that's probably been around the longest is the machine learning aspect on top of computer vision. So this is the system's ability to identify an object, classify an object, and then make sense of what to do with that object. Conflict analysis is just a matter of understanding those trajectories, understanding the data sets of how fast, how close, how they move around. And I did choose purposely a less aggressive conflict here. Some of them can get rather scary, and I don't want to show some pretty gruesome things today, but in our conflict analysis, it shows how close some of these objects can get, which allows cities to actually predict or produce countermeasures before unsafe things happen. So now you have a much higher resolution of objects and data moving through the network. Not only the classification and understanding of the vehicle or the object, but its speed, its movement, its temporal separation, all of these types of behaviors that exist all simultaneously, which produces a large data set. Then you layer that onto the traditional performance measures of delay, occupancy, the coordination effects, different types of split failures and trends, like basically a large set of performance measures of progression, and layering in various different types of mobility perspectives. And then lastly, just the connected vehicle aspects. How fast are some of these emergency vehicles are moving? Where are the transit vehicles? And really start understanding how they are also trying to move through the network, because ultimately safety is key. Moving emergency vehicles through an intersection is key to get to those critical moments where seconds count, and we need emergency vehicles to arrive on time and safely to save lives, not cause unsafe conditions that cause injury or a fatality along the way. So in any case, think all of these data sets coexisting together. That is what we call the intelligent mobility platform. And the main underlying piece of technology there is really understanding the unified data model. So this is where Gen AI starts getting exciting. This is where AI really starts to blossom. When you have a unified data model, you can start building what we call the semantics layer. You can start building the context layers. You can really start attributing your data to mirror into other data sets that give Gen AI wings to fly here. So let's break down the AI for a second. So I talked about computer vision there. Computer vision is the one we probably all know the most. It's been around the longest. This is developed with an additional reinforced learning model. So think like a dynamic flow, self-learning loop where we're understanding not just the computer vision objects that we've learned in models, but now we're starting to apply a reinforced learning process to improve those models, improve operations through a self-learning mechanism. So we're starting to increase the capabilities of those original AI components and really starting to understand how they can improve dynamically through just understanding models and building. So then the next step is the third step, where we start seeing a lot more activity around these days, where it's more around predictive. What do we think will happen in the future? What is the forecast about to be? How do we get ahead of the problems through predictive models? So not just what was it, but what do we think it'll be? And we can take in considerations of existing conditions, weather, understanding patterns of time of day, basically all these different attributes while you're also receiving live data, event data, construction data, basically layering all these things together, you can end up with a predictive machine learning model that allows you to get proactive in anticipation of some event happening or congestion happening. We often refer to this as traffic response. Adaptive is probably the most aggressive version of predictive operations, where it's happening in real time at an intersection. We see a congestion, we see a flow rate, we understand what is happening, and we're making cycle by cycle changes. That is a very aggressive mode to do adaptation around an intersection. But this is all based in that predictive, schedule focused future view of the data sets. And then lastly is where we're pushing into right now. And this is where I'm going to start focusing a lot more on the AI components. This is where we take all of those data sets that I was just talking about, and all the different concepts of all these different pieces that agencies have been trying to apply, trying to collect, and trying to understand, and we make that data more accessible. We start doing generative AI that allows us to produce um, charts, allows us to produce different views of data sets, allows us to in real time take that complex data sets and form it into outputs that we can understand, and then attach that to natural language processing. So think LLMs, large language models, where we're trying to now understand what the data is telling us, apply it to principles, and apply it to effectively become an additional team member on the traffic agency, actually trying to solve traffic problems with all of this in mind. It starts out as defensible recommendations. It starts out as I think you should, I think you could. It starts out as these are your options. But the next stage, probably into number 5 that's not listed here, is getting into the autonomous layer, getting into the pieces where agents actually start working for you um, beyond just the generic recommendations. And I'm going to show you some push toward between that generative AI and towards where agents can start helping us. So that gives you a little bit of an idea of the landscape in our industry today that we see with AI. So let's break it down a little bit further. So the equation for this to work in the platform starts with three major pillars. So intelligence is the number one. So this is your domain specific LLM. This is the specific traffic engineer principles put together into a large language model. Think about it, all of the book smarts that need to exist for a traffic engineer. This would be your textbooks, your principles, your MUTCDs, your HCM models, all of your localized, customized intelligence around what do you do with all this data? And it is your book smarts. It is very much the idea of what a traffic engineer would learn throughout the school process. The second is observation, the context, the data. This is the actual information that we're trying to apply the intelligence against. So think access to maps, the telemetry data, the detection data, that safety data I was showing you, all of that context that is generated and unified into a single location. That is the observational components. That's the context that we need. And then the last is tools. Tools are some things that you wouldn't necessarily think about, but these are the guardrails. These are the skills that we often call them, where it may seem obvious, but something as simple as generating a map. I want to put these data points on top of a map, generate me a map. A specific skill would be the creation of a map. Another skill could be the use of CSV. Another one could be the understanding of a device context in diagnostic terms. Another understanding of what is the structure of a timing plan and what are the guardrails of a timing plan that match the MUTCD type data sets. So skills are very specific, tailored perspectives that we need the response to come with. Think I want a map with icons on the layer. I need to know how to make icons. So all these different skills get built up on top of the AI tools to allow us to generate reasonable responses. You put these three things together, and this is where agentic AI comes out. This is where real interactions with all of your data become conversational and become intelligent in the response itself. But this is a big leap. AI is a big leap for our industry, and we recognize that. And we also have very complex problems that exist, and we can't just assume that AI will get it right. There's a common terminology that exists in the AI space that is called data hallucinations. And this often comes from the lack of skills or the lack of context or the lack of intelligence built into the system, where the response doesn't necessarily go all the way or isn't necessarily comprehensive enough to actually create an output. So human-centered orchestration is a main key factor of all of this. I don't want to suggest that AI is perfect. I don't want to suggest that AI will have all of the context to make the right decisions in every case. That is why traffic engineers exist. What we're trying to do with AI is accelerate the capacity. Some of the cities I work with have a what seems like an unlimited amount of citizen complaints that exist, and they just can't keep up with the citizens. They just can't keep up with the data. The purpose and the application of AI today is really to get that capacity, to operationally increase our ability to improve the operations, improve our workflows, and actually create those outcomes that we all really want to do, but don't necessarily have the time to. So it is very critical point here that AI is not replacing, it is enhancing and it is helping and give us a clear view, more holistic approach to our traffic workflows. All right, so let's get into some more fun pieces. Let's actually look at the MyoVision specific Gen AI agent that we have developed and launched into the platform. So this kind of came from us working with hundreds of cities now that kind of share a lot of that same problem that I was just talking about. They share the capacity challenge. They have small teams, they're fragmented systems, and they do a lot of things manually. My most common analogy or common comparison, I guess, that I would make here is what I call the six monitor problem. If many of you have a traffic operations center or a traffic management center. It's often a giant room of monitors and TVs, and you'll often see individuals sitting at a desk with six monitors in front of them. And that's often because they have six different things that they're trying to monitor and they're trying to understand all at the same time. And that's very fragmented. They are the integrator of the system themselves. Those individuals are effectively the integrators. So these fragmented systems are what we're trying to solve for. We're trying to connect the dots and turn some of these manual analysis components into accessible data workflows, accessible operations, and reduce that heavy lift to actually get that job done. Like a lot of the people we've worked with, the main we took this from a little bit of a survey that ITS America or AASHTO did years ago, not even years ago, just a handful of years ago, where most cities are saying that performance data, intersection data, all of this sounds great, but I just don't have the capacity. It's too difficult, too much time. We just can't get it. So lots of data points to just build on the point that AI is perfect for helping our industry move faster. So what is Mateo? Mateo is actually our persona of our AI agent. Mateo is an AI-powered conversational assistant with that domain-specific AI or domain-specific LLM that is built into our platform. And we personified it. It's called Mateo. The original name Mateo actually is an acronym. It's Myovision's Automated Traffic Engineering Operator. That acronym is a little bit of a play on words of a PTOE. If you're familiar with a professional traffic operations engineer, Mateo's a little bit of a play on those words in the sense that we're trying to mimic that skill set. We're trying to get an AI agent to operate like a traffic engineer, like a traffic operation analysis, and start supplementing and accelerating our existing traffic engineers. So Mateo was born out of that mindset and was born out of trying to accelerate these operations. But effectively, it's your co-pilot. It's effectively trying to solve these problems alongside you and help enhance you. So how it works, and I kind of covered this a little bit already, but how it works is you give it a question. So think conversationally. Give it a question. It'll break down the question into manageable steps. So say I want to know what the total number of pedestrians are. So say, okay, well, what intersections do I have? What data sets can I ask? What can I actually go and get? Look at all my data sources and then query each one of those data sources and then synthesize an answer for the outcome. And that is a basic question, basic conversational piece of asking a data set on what I want to know out of it, saving you incredible amount of time of actually hunting through all the data sets. Earlier, you saw an image of a map, and the image of the map showed, I think in that particular city, there's about 570 locations producing count data. If you were to ask what intersection has the highest pedestrian volumes, it would take you a while to answer that question. You'd have to go to each intersection and pull up the report, compile it down, and really start understanding it, or create API approaches where you're querying it, you're building your own little applications to do the same effect. Basically, what this allows you to do is interact with that data very conversationally and get the outcome significantly faster. So what it looks like, and I use the words conversational, so it's very much a chat interface. There are two things I'm going to show you. I'm going to show you the chat interface first, and then I'll show you um, the AI studios where you can actually get really creative, but it's basically embedded on top of this data set or on top of the unified data model so that you can interact with it conversationally. So just some items to be aware of or to think about when you're interacting with a chat interface is it is context aware. It is able to produce visualization. It does provide you with suggested prompts. Suggested prompts is a very interesting part of what we're learning with all of the cities that are using, and I would say about 50 to 60 cities are now interacting with this on top of their data sets. And what we're learning is the questions, the prompts, where do I start? The change management of integrating it into my data sets. How do I interact with it? What do I ask? All those types of things are turning into educational materials. They're turning into potential um, potential learning modules or potential classes that we can start providing through groups like ITS America to teach prompt engineering, to teach data integrations. And it's becoming a very interesting part of this adventure of AI of how do you actually work with each city to put these components together. In a chat interface, though, you can kind of cut some corners. You can give it specific links, you can give it specific attachments. So instead of integrating everything together out of the gate, you can actually just simply give it information. Think like Notebook LM. You can give it attachments, you can give it context, you can give URLs or existing databases just directly in the chat, and it'll help form answers around it. And it allows you to share that information within your organization across each other so that you can build on it, you can talk about it, and you can support multiple different types of queries. This also has allowed us to bridge gaps of language barriers. While our platform doesn't necessarily work in all languages, chat LLMs do, which allow you to work in it in any language that you want, and it will support all of them. It's a very powerful way to bridge adoption gaps. All right, so let's get into a little bit of a use case here. I'm going to build on this through a few different components. I'm going to specifically use safety data because I find safety data just more robust in how we view some of the challenges in our industry. Safety is a priority number one for almost every city I work with. Everything else matters less than safety. So if we can keep our roads safer, then we can maybe prevent fatalities and um, also build our data sets around or build our perspective around keeping these more vulnerable road users safer at the intersections as well. But safety comes with a lot of context. So building out this context and this perspective for a second, I'll take like maybe a subset of this when I do my demonstration. But when we think about safety scenarios, there's a lot of layers to that problem. It's not just a vendor or not just a computer vision technology saying there was 5 critical near misses. There's a lot more to understanding what to do with that. So think historical crash outcomes. How long has this been going on? How impactful have these crashes been? What is the existing data set? So think historical outcomes. Then there's the physical environment itself. Like, if we actually want to understand how to make an intersection safer, we really got to go as far as how is it designed? What is the intersection structure? What are the lane widths, the medians, the turn pockets? Part of one of the activities that we've done as an organization is trace out the topology of all of the intersections across North America. Initially, the purpose of that was actually to understand how to do connected vehicle type ecosystems, but it has expanded well into the data sets of actually how to apply conflict analysis data. And our agentic AI is actually putting these components together for us in a very exciting way. So think, where are the sidewalks? Where are the crosswalk types? What are the bike lanes? What are all the facilities that we need to think about? And then the next section is where a lot of data comes in. So those volumes, the crash rates, the speed metrics, all the different data sets that I've been talking about that you're layering on top of the actual design. And then lastly, the human context. This is a piece that many technology vendors often forget about. We forget that it's not just about detecting, or it's not just about what is happening. It's also about why is it happening? Like, is it near a school? Is it a transit hub? Is it a commercial zone? What are the census data in the neighborhood that is changing the priorities of why we're investing in certain areas more than what we're doing in other areas? So that human context, that land use is a critical component. And this is the main component that cities need to provide into the data set. The most common one that I see is schools. So where a conflict with pedestrians related to schools in particular neighborhoods. Those different data sets have historically existed separately. Putting them into unified data models allow you to do really, really clever things. So let's start conversationally. So conversationally, we can ask we can build on some data sets here. So let's start with a question. What locations have the highest near miss conflict rate? So again, I was looking at an org here when I did this one. It had about 570 locations. So what it's doing is it's taking my question, building context around what I'm actually looking for, what is the time frame. I didn't give it a time frame, so it's actually saying, well, let's just choose the last 7 days. And now it's going to work through all of those intersections understanding what each ones are, and then produce a list of intersections with the top conflicts. So now it's giving me a suggestion. You want to go deeper on three of the top locations. Let's break it down by severity, type of day, time of day, conflict type over the past week. And it's breaking it down. It's really trying to get deeper into this data set from my fairly basic question there at the beginning. So now it's going to break down that severity for me, conflict type, and then break down the top 5 locations for it. So what it did there is break down the severity of critical, high, medium, and low. Critical meaning it has the potential to create a fatality. High is it's severe injury. Medium, it's more of like an insurance, maybe minor injuries. And then low is mostly low speed. Then it breaks it down by conflict type. Is it vehicle to vehicle, pedestrian to vehicle, cyclist to vehicle? And it's summarizing it with some key findings of which intersection has the highest critical conflicts, which intersections have the highest pedestrian conflicts. And then I've asked it to put it on a chart. So like just create me some basic charts that I can use to talk internally or to talk to my colleagues, or even better yet, create a council ready report. And you can see it's a very interactive chart that it created. So that is just a basic workflow. And the best part about that workflow is I didn't really cut out any time of how long that took. That is actually more of a recording of me doing it fairly real time there. I did copy and paste my question, but you can see how fast it's responding to me and how fast it's producing the data. It's combining the conflict data, the severity data, and the types all into a nice summary for me over the last 7 days. Granted, I do have all of the charts and all of the tools to go and investigate that answer myself and validate that those answers are real, but it gave it to me in a nice summarized way for a quick answer if I wanted to build a report. So let's go a little bit further. So AI studios, so chat interfaces are great. Chat interfaces allow you to access data. It allows you to interface with it. It allows you to really understand a specific question. But what we learned from our cities is that cities often want to do reoccurring investigations, or they want to build charts, or they want to build dashboards. So here we put together a thing called AI Studios. AI Studios allows you to basically build dashboards. It allows you to take your data sets, it allows you to take your visualizations that you're wanting and ask Mateo to build me a workspace, build me a dashboard. This does a couple things. One, it allows you to combine and visualize different data sets in unique ways. It allows you to take large data sets, contextualize them across a large region, and it allows you to customize charting, customize perspective. Think like the dynamics of product development are now changing rapidly. No longer do you have to submit a product request to a company to go and build you a report. The product will do it for you. Just ask it AI Studios to build me a dashboard around pedestrian activity in the Kitchener downtown along the King Street corridor. And it will actually work through this. It'll produce the HTML. It'll produce the actual code to create the charts that combines volumes, compliance, conflicts, and put it on a map to visualize all of that data. And my favorite part about this whole demonstration is that I didn't cut any time from it actually producing the response for me. It is actually working through it almost in real time here based on that question across an entire King Street corridor, which I forget how many intersections it said it would, but it did say how many in the feed there. So it is actually telling you what it's working through. It's actually really breaking down it and trying to put it together in a very fast pace. So it said, good, I have everything. Now let me save that workspace. So let it put it on its map. And now you can see it's created me a dashboard basically from scratch. It's allowed me to put data layers together, volumes, compliance, and conflicts. It's allowed me to interact with features like map, KPI cards, daily trend charts, and I can constantly iterate on this if I wanted to. I could say change the way the map looks, change the way the pedestrian volumes look, and basically interact with that data set. So it's a very compelling way to customize the way you want to work with your data or put the data sets together in a way that it allows you to solve the immediate problem and save it as a report. So up at the top, I don't know if you can tell, but it says private right now. So this is a private dashboard that I'm building for myself. If I wanted to share this with my organization or share it with MyoVision or share it with um, different groups. So like think if you have different neighbor communities that share corridors, you can create dashboards around your part of the corridor and share it with a neighboring organization all through the platform to say, this is the dashboard I have of my data. Would you like to look at the corridor so that you can optimize your corridor and vice versa? So you have the ability to share these perspectives and you're able to really understand it. Um, I did see a question there. After it builds the dashboard, are you able to see a report or summary of the assumptions it made? So this is something that is in the workspace folder that does exist on the one page where you can go into the individual data sets. We are working on better ways to compile it. The way it works right now is it points you to the raw data sets and gives you the chat history, allows you to just see the process it went through. It doesn't necessarily show you the assumptions, and we're working on making some more of that visible to help with the trust aspect of it, actually trusting what it's producing, validating if it's giving you the right answers. And specifically, if we're getting into more technical components like give me summaries of NTCIP configurations of this controller, how do I actually validate why it compiled different ways, like think active plans versus time of day plans? It can really give you the one it chose to do. We're trying to work up better ways to surface that and more easier to interact because we want it to be fast, but it's something that we've heard from a few different cities that they want better access to that raw data. So yeah, gives you an idea of what's possible in an AI studio. You can build on this quite a bit and show lots of different ways to view the data set. Let's go one step further than this. So I skipped out a couple parts of it here, but I wanted to get a little bit more complex with um, how I want to visualize some of the data. And this is where it's almost as creative as you can go with it, in the sense of I actually asked Matteo on the right here to build me a prompt that would have all of the components that I would care about if I were to build a dashboard around continuous safety heat mapping. And it actually produced its own prompt to can tell me what I would put in there. And I just copied it into Studios and had the Studios build what Matteo thought would make the most sense. And this allowed me to create a control bar where it understands, like, I want to look at different things like certain time ranges, certain intersections, different types of interactions, vehicle to bike, vehicle to ped, severity types, speed types, maximum what we call post encroachment times around how close are objects. Basically, put all of those pieces together for me, figure out how to overlay it onto a map in terms of heat mapping it, in terms of severity levels, allow me to autoplay conflict clips, sort different ways, and then ultimately overlay it onto a map. So as you can see in the little clip here on the left, it took all of the different severity points that were captured, geolocated it on the map for us, put in the cluster of where was it in the intersection design. So I'll let it maybe come back to it here in a second. And then allow me to interact with each one of the data components itself. So you can see it kind of layering on top there. It looks like a heat map. It looks like a visualization adoption of how and where conflicts are occurring at this particular intersection. The university that I went to is actually right on the southwest corner of this intersection, and it's one of the highest pedestrian locations in the city. And unfortunately, there's been multiple fatalities in the last 6 months at this location, so it's been a hot spot for some of the cities I work with, for what the city, this one in particular that I work with. And particularly on this crosswalk, there was a near miss right on the edge there where a pedestrian started walking out right in front of an oncoming car. And you can see the conflict clip that was captured on the right. So now I can interact with where are these conflicts happening, the severity of these conflicts, and even the video of these conflicts, all in a custom made dashboard in a way that I can interact with the data. And this is, again, as creative as you can make it effectively. You can layer in these data sets. This is a very intersection focused perspective of that safety data. You can go even further and say, now take that and go to the entire network and do something exponentially larger. Let's create a 3D view of that data set on top of the map. And obviously, this is a little bit, um, I guess, basic in that sense, but I asked it to create a 3D map of where all the conflict data is occurring around the city and allow me to normalize it by volume. So compare it to by volume and let me normalize it so I can actually find real hotspots of conflicts. So think date ranges, the severity types, overlaying that with volume, and then looking for very particular scenarios and overlaying it on top of the map. So there's a lot of different context here that you can view and put different perspectives around and then just categorize it in a way that you can filter it. So if you want to know what is the highest speed intersection, you can filter by what is the average highest speed, what are the percentage of critical conflicts in comparison to the total conflicts. And that's a key attribute of working with sensors at the side of the road that give you better granularity. I don't necessarily care about all conflicts. I care about conflicts that have the potential to create fatalities. And how do I compare my data set specifically to those? You can kind of see on the right here too. Sometimes you have to push the data sets through. So you have to keep asking, I want to iterate it this way. Maybe it didn't render the chart the right way. And you just basically ask Mateo to fix it for you and build on the data sets. So just the last step of this layer, I did something very simple just to show the point. Give me an overlay of the schools in the city here and overlay that on top of where the critical conflicts are happening at the intersections as well. So now I can see in relation to where my schools are, in relation to where the conflicts are happening. That doesn't necessarily, if you don't have enough coverage, that often helps you point to where should I put more sensors or where should I give additional focus. Schools is just one type of layer, and if anyone's familiar with groups like Esri, Esri has a much more robust map, and we're starting to work directly with Esri as well, where we can integrate in both directions some of the GIS tools that Esri has, as well as the agentic AI tools that we have, and start getting really creative with how data can be visualized, especially in areas where you're already leveraging tools. You're already leveraging tools like Esri. You already have some databases. Integrating Mateo through what we call MCP servers or model context protocols in a way that you can add contextual layers to existing data sets to allow for some simple integrations. So between us and Esri, us and TomTom, us and modeling software, us and different types of count software, us and different types of citizen complaint software, all those different things become integratable, but also don't necessarily change where you work. We can simplify it with AI, but not necessarily have to replace everything you're doing. Let's just amplify what you're doing. So in the last few minutes here, I'm just going to just cover a few different real world use cases just to give you an idea of where we're seeing cities take some of these applications, and then I'll stop and open it up for some questions. So the first is the citizen complaint workflow. Citizen complaints are the major focus I think a lot of our cities are using. It's the backlog of all the things that need to be done. The light you get input from your citizens that are like the light is too short. I always hit the red. Pedestrians don't have enough time to cross. So the questions or the complaints are actually very simple, but the data sets and the outcomes are very complex. So you can take in this information through multiple sources. You can use the prompts or you can build on top of the prompts and you can interact with the question itself. And then Mateo will actually go through what is the signal design, what are the signal lengths, where could the issue be, is there validity to the issue, and then actually do that initial assessment. Our goal is to get a city so that when the citizen complaint comes to the traffic engineer, the AI agent has already told you everything it knows about that issue so that you're starting from a point of informed context, not from a point of, I need to go figure out what the citizen is saying, but more so from a spot where you can get directly to work on the issue itself. This will allow you to accelerate your process and start moving forward. To do this, we're actually integrating with tools like C-Click Fix, MS2, even Parsons. We're starting to talk about how we can integrate the citizen complaint workflows to really improve this process. The second is proactive network monitoring. So this comes from More of like the operational aspects, I would say. So, like if you have a large network of cameras, one of the more common things that comes out of cameras is how do I know when to clean my camera? The best part about AI is it can actually go and look at all of your cameras and tell you which ones need to be cleaned. So you can assess each one of the snapshots and understand how to make a or what the issue is, where to focus, which ones you should go visit and clean physically, and even give you um, almost like a pathway or a work order of what to do. Configuration is a common one. How do I know if my intersections are even configured? That's giving me the right amount of data. So we talked a little bit about hallucinations. AI often isn't hallucinating. It's just revealing that you're missing or you don't have the real context. So a very common request that we see or a very common prompt that we see is, can you validate that you configured my intersection right based on the controller so that I'm actually getting confident data from your responses? And then just basic analysis patterns or alert patterns that we're seeing around which intersections have the highest alerts, which ones lose power the most, all the operational aspects. The next one, signal timing and safety. This is a common, more deep analysis where you get into how do I assess the way my intersection is programmed? How do I assess it against existing standards, existing interval guidelines that I have? How do we know that it is actually programmed the right way? How do we actually dive deep into the safety data, similar to what I was actually showing you earlier? How do we unpack some of these data sets and get to the heart of a countermeasure that we want to deploy and actually do before after type analysis. And then a very basic one that we actually see a lot of is how do I validate left turn warrants or permissive protective left turns? How effective are they? How easy are they to use? Basically, chipping away at all the different activities that we may need to do. Use case number four, operational workflow acceleration. So this is where you get the bigger bang for your buck. This is how do I do multiple intersection volume comparison in real time? So how do I compare it to multiple intersections? How do I do it holistically? If I'm making a timing plan adjustment at one intersection, how do I view the impact of that at multiple intersections in before after type analysis? Or how do I compare one intersection to another? How do I do large scale device troubleshooting or large scale asset management? And then even aspects even more complex like transit operations. Transit agencies are often focused on how do I improve my route optimization. That comes with a large collaboration with the traffic teams because we need to collaborate on how the signal works, how priority works, how their routes are mapped, how their travel time works. And it's a very complex, operationally data heavy process. By combining these data sets into basic transit performance checks, you can compile these together and get to the root of issues much faster. So that's a lot of information around uh, unified data models, intelligent mobility platforms, complex use of AI algorithms and agentic AI tools to really help accelerate how well and how effective we are at making our intersections more efficient and safer. So I hope that was informative. I have a few minutes here, or 7 minutes here to answer any questions. And thank you so much for all the time today.
Thank you, Brent. As people maybe add some questions to the chat box, I have one to get started. So you mentioned about having all the data that you need for near misses, having the data for arrivals on red, having maybe even data for left turn warrants now. Does the system has the capability of recommending things? Let's say I know it gives me all the data points. I can see that there is an issue, but does the system itself has a potential to provide you a recommendation?
Absolutely. So it has the construct of a timing plan. It has the construct of, or the understanding of all the design principles through the LLM of what a timing plan should look like. And it has all the context of the data sets. So the way it works is it'll actually assess whether you do it through like a green band analysis or whether you do it through a coordination analysis. It will allow you to one, review that data, and it will also provide you with recommendations of where you can increase time, change time, or improve the overall timing plans itself. Um, So it gives you those recommendations. We're actually now starting to think about how we integrate with ATMSs and how we actually integrate directly with traffic controllers to give the ability to easier push those timing plan changes that it recommends directly to the controller after you've had a chance to review it. So absolutely starting to produce recommendations, and it's also starting to index those recommendations across networks. So we're really starting to understand what that looks like city to city and what those decisions are and how they're being made. So, yep, absolutely.
So Cam is asking, can the system be customized to fit the specific standards of the agency using it? If so, how?
Absolutely. We actually, I didn't get a chance to give this example because it literally was added yesterday into it. There is actually now a section in our platform where think like Notebook LM. It actually has a spot where you can drop your specific standards into it as the base level of context. And you can do it in a couple different ways. One, you can drop the documentation. You can copy in notes of what standards you want it to follow, but you can also have general configuration policies like um, I don't want any cross times less than 10 seconds. You can put those basic parameters into the call like settings box or the context box, and you can give it that context so that every time it responds with that in mind. So you can provide it with that information and it stays static as a part of this system. And it's a very common question that most of our cities get. So, or most of them ask us. So we literally just added that yesterday to allow you to holistically do that.
Awesome. So another question that, at least for me, usually comes to mind, Brent, is what is the amount of investment? What's the level of investment that cities, for example, per intersection have to, and I'm not looking for a specific number here, if it's 10,000, 1,000, 100, a million or something, but just can you speak a little bit about the level of investment needed by a city to get to this point for to get the same information that you're getting out here and providing to us?
Absolutely. Think in terms of data resolution first. So one dimension is the data resolution. So we have one of those applications that I quickly mentioned at the very beginning was called Network Core. Network Core is free. You can actually integrate Network Core into your city and it will produce the map that we were looking at the beginning. It'll allow you to connect into each one of your intersections with the existing sensors that are there with your existing traffic controllers. And that as a base layer is free. You don't have to actually pay anything to do that. It's just leveraging exactly what you got. So one dimension is the data sources. So to get a basic resolution or to get a general resolution, you can just connect in and use what you already have, your controllers and your existing detectors. Higher resolution would be adding more sensors like video-based, LiDAR-based, radar-based, adding in those sensors, adding in those APIs to get higher granularity data sets. Those could be purchased from MyVision and those have a cost to them, or you could already be purchasing those through other vehicles, but that data can all be leveraged. So there's a good, better, best scenario on data resolution, and that has different costs on each one of those, with the base layer being free, use what you already got. So that's dimension number one. Dimension number two is prompting. Prompting, if anyone's familiar with ChatGPT or Claude or um, what is it, Copilot, any one of these different types of applications, they're prompt based. So what we've done to try and simplify the problem is make the cost predictable. You can't really base a price on an engine like this by the number of prompts. So what we've done is we did a same small, medium, large type package on top of the platform that allows you and the rest of your colleagues at that agency to effectively use prompting unbounded, so unlimited. You can prompt as much as you want, and that will allow you to interact with the data sets and not have to worry about the per prompt cost that exists in these types of LLMs. But MyoVision has packaged that in a very simple ways. But again, think small, medium, large. When you have a smaller city, you're not going to be prompting as much as a large city. So we've kind of right-sized the pricing to be in that group, and you're in the magnitude or the comparison point that you can use is an FTE. So think the cost of a person. In a small city, your price would be about a third of a person. In a medium city, it'll be about two-thirds of a person. In a large city, it'll be about a full 3 out of 3, 3/3 of a person. And that would be how you can benchmark the cost in relation to a whole additional person on the team. So whatever scale you think about that in, that's about the cost that you would be attributing to the small, medium, large.
Thank
Hopefully
you.
that in.
Yeah, that was good. Uh, we probably have a minute or so here. So Adam is asking, is there a possibility that prompts or suggestions conflict? If so, how would those data points be resolved?
Yeah, I mean, it's a good point. This is where the human in the loop, the traffic engineer that's smart, has to make some decisions from the information that is being given. Sometimes it depends on the context of the question in the sense of if you answer a question only with the perspective of a single intersection and may give a recommendation like you should add 5 seconds to the left turn because you need to clear the queue of this left turn. But then if you ask the same question of what would you do with this left turn, but consider the intersections around it, it may say don't change the timing, you don't have the capacity on the time to put more vehicles to the other intersection, meaning don't change it because with more context, I would recommend something different. So, to some degree, as the traffic engineer in the loop, you have to make some decisions on how the suggestions are being formed and the level of detail it's being formed from. And this is where it's critical that the person is in the middle to make those decisions. So, most of the time, when we see conflicts in suggestions, um, it's because the context switches or the expansion of context changes and we need to make a decision from a different perspective. And you'll see this happen over time, where you're changing the view or you're changing the data sets and it will refine the answer in that given moment. But that is the main point that does come up. You can get multiple answers on a question, but it's almost always a difference in context of the question. So I don't think I generally see like if you ask the same question 3 times, you get 3 different answers. It's more so if you change the same question 3 different ways, you will get 3 different answers because it's considering different things.
All right.
Hopefully
So,
that, hopefully that
yeah,
answered that.
thank you, Brent. There's one more question coming in, but let me just say this: if you need to go, if we're over the 1 hour limit here, so anybody that needs to go, feel free to do so. I put my email address there just in case we had a few folks that were not able to download the presentation. So if you still cannot download, like have the presentation, just send me an email. I'll share that with you. And with that said, I would like to say thank you to everybody. Just keep an eye on our calendar. And if Brent has 1 more minute, we'll just answer that last question there and again end the session here. So, if the machine agentic is so smart, the deeper knowledge contained
Oh,
in
sorry.
humans may be somewhat less used and lost. Can you use the soft water to continuously challenge and train human agents?
Yeah. I mean, it's a very, very interesting point, right? Like, do we get duller or less less sharp because we don't need to be as challenged as often? Maybe that's true, and maybe that is a good thing in the sense that um, the more complex questions are being handled, we can get more to decision making than critical deep dive on the data. But then the other part of my mind thinks about moving up the value chain a little bit, and often applying our deeper knowledge is in the decision making part, less in the compiling of the data part. So somewhere in the middle is how would you make decisions from different perspectives, or how would you make decisions from it, and what critical thinking do you need to make sure that you're considering? And that's maybe where we need to figure out how to gamify or challenge the user to make sure that they are considering everything. So instead of just making blind changes or taking the initial recommendations, challenge the user to consider different aspects of the problem to see if we can guide a more holistic approach. But I mean, this is part of the learning experience with agentic AI is how do we improve the human nature or improve the outcomes that we're all trying to create without having a negative impact in the long run by not actually getting the outcomes or not actually designing things the way we want. We can't allow AI to just take over. There's a critical point in all of this that decisions and structure need to be maintained by the human, and that's going to be critical as it grows. So I don't know, it's a fascinating topic, and we could probably talk all day about the ethics, the psychology, a whole bunch of different things here, but we're learning. We're starting to get a lot of feedback from a lot of different cities around how this can be applied. I'm also starting to work with many different academic agencies where they're challenging some of these aspects as well. And I hope as an industry we tackle some of these very complex, nuanced questions.
All right. Thank you so much, Brent, for your time, and looking forward for the next one. And thank you for everybody that participated today. And we will see you on our next webinar. Have a great day.
Thank you so much, everyone.